With this video, I wanted to go over the algebra of functions in section 2.2, but mainly I want to focus on the domain and range, mainly the domain when you're dealing with functions, because domain is an important concept in pre-calculus, and sometimes a lot of students need a refresher on domain and range. So I put in a couple of links that you can copy and paste and just watch some of these videos about domain, um, range, and domain of algebraic functions. Just a kind of recap. This is what a kind of the thing I use when we're doing for graphs is if you want to find the domain, remember the domain deals with the x values. That we're looking left and right horizontally. How far left? This is the two questions you need to ask for domain. How far left does the graph go? And how far right does it go? If you look at where the starting and stopping points are for the domain, left and right horizontal, that will give you the domain of the function of the graph. And if you look at for range, how far up does it go? I'm sorry, how far down does it go? And then how far up does it go? In this order. This will tell you the range, and again, we're looking at the y-axis of the graph. For this particular part of the video, I'm going to really focus it on just looking at functions. So I want to first talk about domain and what it really means. Domain will be the answer for a domain will be all real numbers. What does all real numbers mean? All real numbers is when you have that any answer, any number that you can think of will work for that particular function that we're talking about. So when we say x is equal to 5 or x is equal to 1/2 or x is equal to -10, those numbers will produce an answer from the function. There are only three cases where the domain will not be all real numbers. And here are the three cases. If you see a fraction or a division, when you have a numerator and denominator, this is where you're going to run into a red flag. Because what is the red flag? X cannot equal 5 in this case. If I plug 5 in for x, 5 minus 5 for this function here is going to be 0. What happens if you have 0 on the bottom of the denominator of a function of a fraction? It's considered to be no solution or undefined. That's where our red flag is. So basically what this is saying is the domain for this function 3 over x minus 5 is going to be all the numbers except for 5, because 5 is where it gives us a problem. I call it a red flag. 5 is going to give us a red flag because it's going to be undefined here. So again, you can pick any number that you want for x, but you just cannot pick 5 for this particular graph function. So how do we get 5? If you have fractions, all you do is set the bottom part equal to 0 and just solve for x. That would give you all the numbers that you cannot use. So you can use all the numbers except for this one particular case, 5. Even roots. For even roots, this is where we have the square root. What do we know about square roots? Inside a square root, you cannot have a negative number. You cannot take a square root of a negative number. So basically what I'm looking for is the inside has to be positive. So if this inside here, x plus 3 is greater than 0, anything greater than 0 is considered to be a positive number. Wouldn't that be correct? So this is where we're going to use the greater than or equal to for 0. And yes, the inside can be equal to 0. It just can't be a negative number. So once we solve, here's my domain for the square root of x plus 3. The x, you choose any x that you want, any number for x that you want, but it must be greater than -3 because those numbers is going to work here. That's always going to produce a 0 or a positive answer, which we're allowed to take the square root. Anything other than anything greater than or -3, it's going to produce a negative answer inside the square root, which causes a undefined and no solution. Again, a red flag. So again, for this one here, use the greater than or equal to symbol, set equal to for 0, solve, and that gives us the domain for this one. The last one is if you have both. See, I have a fraction and I have a square root in the denominator. So this one here, we're just going to put square the greater than symbol. Again, we didn't put the equal to like we did up here because the bottom one cannot equal 0. Remember what happens when a 0 on the bottom is undefined. And then if you have a negative inside this square root, then it's going to be because it'd be undefined also because you cannot take a negative a square root of a negative number. So again, we just take what's in the inside, put the greater than inequality sign here, solve for it, and then again, what this is saying for this function, you can choose any x that you want, but it must be greater than 2. And that's going to be the domain for this one because it produces an answer. So again, if you don't see a fraction, if you don't see a square root, or you don't see both together, the answer is always going to be all real numbers. So a few examples. For each one of these, they want you to find a domain when we add the two functions together, subtract them, multiply them, and divide them. So if I'm adding f and g, so f is going to be signified to be x squared minus 4, and g is going to be x plus 2. So it wants us to add them together. If I'm adding them together, x squared minus 4 plus x plus 2, this is going to be my answer, x squared plus x minus 2. If I look here, do I see a fraction anywhere in this answer? No. Do I see a square root in this answer? No. And I definitely don't see both a fraction and a square root together. So the answer for this one, when we do f plus g, is going to be all real numbers. So once again, if you don't see a fraction, a square root, or both together, the answer is always going to be all real numbers every single time. So if I subtract them, this is my answer. Again, I don't see a fraction or a square root, all real numbers. If I multiply them together, I have to do my distribute properly or FOIL. I get this polynomial. I don't see a fraction or a square root, all real numbers. And the symbol for all real is going to be, you can say negative infinity to positive infinity. So this is what the symbol looks like, and this is what the positive infinity. So you just write negative infinity, comma, positive infinity, and put them both in parentheses. So for this one here, if we want to divide them, this is where we get the fraction. Now we see we have x squared minus 4 over x plus 2. So here's my fraction. Remember, the bottom one cannot equal 2 because what happens, a negative 2, because what happens if I put negative 2 here? Negative 2 plus 2 is 0 on the bottom, which again is going to be undefined or not defined in this case. So the answer for this one is going to be all the numbers except for negative 2. That's what the domain is for this function. But here, if we multiply the two g's together, or we can just square it, we get this function here. Again, there's no fraction, there's no square root. The answer is going to be all real numbers. So hopefully that helps to get a better understanding of what we're going to do with the function when we need to add them, subtract them, multiply them, or divide them, and then the three cases here for the domain when working in MyMathLess Plus or the book.